Welcome to Scale Up University. Welcome to Probability for Machine Learning course. So this is the module 2, lecture 1. That is what is uncertainty in machine learning. So we are starting with the module 2 of this course. So module 2 is uncertainty in machine learning, and this is the lecture 1 wherein we will discuss what is uncertainty in machine learning. So in machine learning, there is like an expectation or like a misconception that if I give enough data and the right algorithm, the model should be correct. So in machine learning, there is a misconception that I can make a perfect model, I can make a perfectly accurate model, I can make a very like a correct model which will give me certain outputs, provided if I train it with the enough data and I use right algorithms. So if I use the right algorithms and if I give enough data to a model, then that model will be perfect. It will be highly accurate, and it's a misconception. It's a myth in machine learning because the reality is, so this is like a myth in machine learning. So reality is predictions cannot be 100% accurate. Predictions are sometimes wrong. The confidence of the variance, sorry, the confidence of the prediction, it varies. It is not like the prediction will be done with the same confidence. The confidence varies, and performance changes in the production, meaning to say that while training the model and while testing and validating it, you might get a very good accuracy. But once you deploy that model and once it encounters real world test data, there the accuracy may suffer, the performance may suffer. So it has been seen often that performance changes in production. So now it's very clear that in real world, in reality, if we talk about machine learning systems, they cannot be 100% accurate. Machine learning systems cannot be certain because there are always some predictions which might go wrong. Confidence varies and performance changes in production. So in this lecture, we will be discussing this uncertainty in machine learning, like why it happens, like in machine learning, why it happens, why the output is not certain, why predictions may go sometimes, like why some predictions may go wrong, why confidence varies, why performance changes in production. And we also look at this is something which is like inherent in machine learning. So why it is not a failure of ML. So we will discuss all this in this lecture. So this lecture is about what is uncertainty in machine learning. So if we look at the topics which we will be covering in this lecture, so first we will talk about definition of uncertainty in the machine learning context. Then we will talk about why uncertainty is the central difficulty for beginners. Because see, the idea is that we are like trained in traditional software development. So traditional software development is highly deterministic. It is certain. Or mathematical models we make, it is highly deterministic. So uncertainty is something which is very new for us because we are not used to like build systems with uncertainty or deal with systems with uncertainty. So uncertainty is something which is very new for us, and hence dealing with it will be like bit difficult for beginners in machine learning or for beginners in the field of artificial intelligence. Then we will compare deterministic systems versus stochastic systems, that is random systems. Then we will talk about why uncertainty is not a bug but a property of machine learning problems. So this is very important discussion we will make, wherein we will discuss that uncertainty is not some sort of a shortcoming or some sort of a bug, but it is something which is inherent, which is there by default in machine learning problems. So we can say that uncertainty is a property of machine learning problems and it's not a bug. So we will discuss that also, that aspect. And finally, we will conclude this course like by discussing what machine learning is really about. So all these topics we will cover in this lecture one by one. So this is the module 2, that is uncertainty in machine learning, and it is the lecture 1 of module 2. What is uncertainty in machine learning? So now we will be talking about the first topic of this lecture, that is definition of uncertainty in the machine learning context. So we will talk about uncertainty in machine learning. So basically uncertainty in machine learning means that inability to know outcomes with complete confidence. So uncertainty in machine learning means inability to know outcomes with complete confidence. Like whatever the outcome of a machine learning model, that will not be certain. Like the outcome will be probabilistic. Inability to know the outcomes with complete confidence, even when we have data. So despite of having enough training data, despite of having some state-of-the-art algorithms or models, so even when we have data, even when we have model, and even when we have some very high computational powers, despite of all these resources which we have, despite of having all this, like let us suppose you are training a state-of-the-art machine learning model with huge data, like terabytes of data or petabytes of data, and you are using like huge computations, like a farm of GPUs. Despite of that, the outcome of that model will be highly uncertain, because that model will not be able to predict the outcomes with complete confidence. There will be always an element of doubt will be there. So now the question is, why is it so? Why is it so? Because you only imagine that despite we are training the state of the art model with such huge data, and we are using like very heavy computations, like some very good GPUs, hardwares. Despite of that, we are not. Despite of that, our machine learning model, it is not able to predict the outcomes with full confidence, with complete confidence. Why? So there are several factors for that. So the first one is the data. It is a sample of reality. So the data observe, or we can say that ML systems, they observe partial reality. ML systems learn from finite, noisy samples, and ML systems, they operate in changing environments. So the idea is very clear. The ML systems which we will be making, so no matter how huge training data you take, it will always be a subset of the entire population. It will always be a subset of the all possible training data. So ML systems will always observe partial reality. And because it is observing partial reality, there are many patterns which it misses. And definitely there is a chance that if I provide input of that sort, input containing those patterns on which machine learning model has not been trained, then definitely it will make mistakes in doing predictions. And machine learning systems, whatever training data we are providing it, whatever finite samples it is taking into consideration, it definitely will have some noise. Noise is something which is unavoidable. And machine learning systems, they are dynamic in nature, because like if I talk about real-time data, so that real-time data is highly dynamic in nature. It is changing with time. So machine learning systems, they operate in changing environments, and that also like introduce some different kind of noise and hence uncertainty. So these are some like very important factors, because of which despite of having huge training data, despite of using state of the art model, and despite of using some very heavy hardware resources, computations, machine learning models are unable to predict the outcomes with complete confidence. And this is the uncertainty in machine learning. Now, I think it is very clear to you when I talk about uncertainty in machine learning, what it means. It means the inability of the machine learning models to know the outcomes, to predict the outcomes with complete confidence. So, uncertainty is about knowledge limits. And what is this knowledge limit? It is basically observing the partial reality. That's the knowledge limit. Because training, if we are training the model, we are training it with limited knowledge. We cannot train it with the entire data. So that's the knowledge. So uncertainty is about knowledge limits, not model weakness. So very important point I discussed, very, very important point. Uncertainty is not a shortcoming of the algorithms. Uncertainty is not the shortcoming of the model or the techniques. You know, na, in machine learning, different techniques we use. Supervised learning, unsupervised learning, like regression is there, k nearest neighbors are there, random forest, decision tree. These are different techniques of machine learning. So different models are there. So uncertainty is not a shortcoming or a weakness of a model or a technique. Rather, it is the shortcoming of the data itself. Because in machine learning, we have to deal with the data. Data plays a very important role. So uncertainty is the shortcoming of data. And what is the shortcoming of data? Knowledge limits. Because the data we are using, it is a sample of reality. It is containing partial reality, and it is also containing noise. So uncertainty is because of data and not because of model. Very, very important point. If we look at one real world example of image classification, so suppose we have an image, we give it to our ML model or image classifier. Now let us suppose the image classifier is making a prediction like this: cat 0.52, dog 0.45, other 0.03. So here the image classifier, what prediction it did was, it took the image and looking at the image, it said that 52% chance is there that that image is of a cat. 45% chance is there that image is of a dog. And 0.03%, like not percent, like 0.03 probability, like of chance that that image is other. Now here this is uncertainty, because outcome is not sure, outcome is uncertain. This is uncertainty. So it's a real world example of uncertainty in machine learning. So we had an image classifier, it took an image and it gave an outcome like this. And definitely this outcome is very highly uncertain, because with 100% confidence, with complete confidence, we cannot say whether that image is of a cat or of a dog or of something else. So this uncertainty. Now this uncertainty is not the fault of the model. So here very important point you should be making note is, here model is not confused. The problem is not with the model. Rather the problem is with the data. Like the image you passed, that image might have some ambiguity. That image might contain both cat and dog. The problem is with the data. The problem is with the image. So if I am getting a highly uncertain outcome, then it's not the problem of the model. Model is not confused. Rather it is ambiguity in the input image itself. So that's the main idea. So this is like uncertainty in the context of machine learning. Now we will be discussing the next topic of this lecture, that is why uncertainty is the central difficulty for beginners. So see, for beginners, it's very difficult to like understand uncertainty or to feel uncertainty, because the beginner's mental model, if we talk about, so beginners, like they are very much comfortable with the traditional programming. So beginners, they always, if we talk about their mental model, they expect models should give correct answers always. So no matter what, models should give correct answers. Because in traditional programming, if the algorithm is correct, then no matter what input you will pass, output has to be correct. But in machine learning, that is not so. Because we saw that in machine learning, the shortcoming is not with the model. Despite your algorithm is correct, if sorry, the data is ambiguous, the input is ambiguous, if the data is ambiguous, if the data is noisy, the model might give wrong answer. Or the in machine learning, the data is a sample of reality, so model can give wrong answers. So the beginner's mental model is that the model should give correct answers, because we are we have been building systems with this mentality from decades. Errors mean something is broken in the system or in the algorithm itself. See, in traditional programming, if we are getting errors, it means 100% sure that something is wrong with the algorithm. There might be some logical error or some other sort of error, but something is wrong with either the algorithm or with the hardware, or if it involves networking. So while transfer of data, something might happen. So error means something is broken in the system. But in machine learning, this is not the scenario, because in machine learning, we already saw errors we get because of not because of the shortcomings in the system, but because of the data. And in a traditional system, traditional software development, more data always removes uncertainty. In traditional software development, if you provide more and more data, it will always removes uncertainty. But in machine learning, this is not so, because we already saw in the previous discussion that despite you train the model with petabytes of data, still it will be a sample of reality. Still, it will not be able to cover the entire, all the possible training data, it will not be able to cover. So these all characteristics, like model should give correct answers, errors means something is broken in the system, more data always removes uncertainty. It points towards deterministic programming. But in machine learning, inputs are incomplete. There might be noise in the data, that is, labels may be wrong, patterns overlap, like multiple features, they might overlap with each other. And most importantly, the future is unknown. And hence, because of this, because see, we are not at all used to such mindset, because whatever inputs we have been using in traditional software development, it is always complete. There is no point of it being incomplete. So inputs are incomplete, that is totally new for us. Labels may be wrong, that is totally new for us. Overlapping of patterns, that is totally new for us, because all these things are not present in traditional software development. In traditional software development, the future is known. Why the future is known? Because if I have devised an algorithm, then I know that, okay, if this is the input, this has to be the output. I can predict beforehand that, okay, if you give this input to this algorithm, this output you will get. But in machine learning, that is not the scenario. So because of these things, because we have never been used with these things, and hence like uncertainty is difficult for beginners. So in machine learning systems, we deal with uncertainty. Okay, now we'll discuss the next topic of this lecture, that is deterministic versus stochastic systems. So if I talk about deterministic systems, so here same input will always give same output no matter what. So in deterministic system, no randomness is involved. So deterministic system means you have a system, you have an algorithm, you have a software, you have a system. For same input, you will get same output. No randomness is involved. If you talk about examples of deterministic systems, like if you talk about sorting algorithms, arithmetic operations. So if you write a sorting algorithm, if you give the same input, the output will always be same. You write any arithmetic operation, for same input, the output will be same. And rule-based logic. So we can say that determinism works when the world is fully observable and controlled. So that is determinism, deterministic systems. So when the world is fully observable and controlled, wherein we know the outcomes with 100% surety, we know the outcomes with 100% certainty, then determinism will work. So determinism works when the world is fully observable and controlled. So in those scenarios, deterministic systems work. If I talk about stochastic systems, so they are random in nature. Stochastic systems are random in nature, meaning to say that outcomes vary. Outcomes vary even with similar inputs. In stochastic system, randomness is intrinsic. So in stochastic systems, you have a model with similar inputs, you will get different outputs. That is something very interesting about stochastic systems. In stochastic systems, randomness is intrinsic. So here, probabilities come into the picture. Probabilities describe behavior better than rules. Now, if we talk about real world systems, the world which we live in, they are almost always stochastic in nature. Now, let us understand it with a real world example. Then it will make like more sense. Like let us talk about, or let us take loan repayment example. Now, let us suppose we have two customers, customer A and customer B. Now, both the customers, they have same income, same credit score, and same history. Despite of that, like just imagine you have two customers with same profile, like same income they are making, same credit score, same history. Despite of that, you will see that one of the customer, he repays the loan, and the other customer, customer B, he defaults the loan. So it's a perfect example because it's a real world example. In the real world example, we see such scenarios. Such scenarios are very common in real world scenarios. So here you see na same input, because input like same income, same credit score, same history. So for customer A, the input is exactly similar to customer B. But if you talk about output, for customer A, the output is he repays, but for customer B, the output is default. So this is the stochastic system we are talking about. And here very easily you can see that why we were not able to predict properly, because the information is incomplete. There are other factors also which influence the repayment. Like customer B did not did the repayment of loan. There are other factors also which might influence his decision, which we haven't considered. So that is the partial reality we are talking about. Sample from the population. So there are so many patterns which we are not taking into consideration. So now I hope with this example, it is very clear how stochastic systems work. So in stochastic systems, for same input, we can have multiple outputs, because for same input here we are having two outputs, either repay or default. So for same input, we can have multiple outputs. And interestingly, human behavior is stochastic in nature. So if I talk about one very interesting example of stochastic system is the human behavior itself, because human behavior is like very complex, very difficult to understand, especially if we talk about women. Like there are so many memes and all, like very difficult to understand what is like what would be the next action, highly unpredictable. So that is uncertainty. You never know what can be the next action. So human behavior is like a stochastic system. So in real world, especially when we deal with machine learning systems, it is stochastic in nature. Okay, now we'll look at the next topic of this lecture, that is why uncertainty is not a bug but a property of machine learning problems. Now see, we already saw that uncertainty is something which is inherent in machine learning problems. It's a property of machine learning problem. it is not a bug. So if we ask a question like, how do we remove uncertainty? So it's actually a wrong question, because when you try to remove uncertainty, what will happen is it will lead to overfitting, it will lead to overconfidence, it will lead to unsafe deployment decisions. So see, the idea is that we should not try to remove uncertainty from machine learning system, because if you try to do that, what you will be doing, you will be introducing overfitting. What is overfitting? Overfitting means the model, it will learn all the patterns of the training data to such an extent that when a new pattern is introduced, it will collapse. That is overfitting. Like, while training and while validation, it performs perfect. But when it comes to production, when it is tested under the real setting, when it is given some real data which it has never seen before, there it struggles. So overfitting. So the idea is that if we try to remove uncertainty, we basically, it will lead to overfitting, it will lead to overconfidence, because see, the idea is that when uncertainty is reduced or removed, then the outcomes of the machine learning model will be certain. So high confidence outputs you will get, and that will be like overconfidence outputs. And if you take decisions using that decisions will be unsafe, that decisions will not be reliable decisions. So if you try to eliminate uncertainty, it usually makes model worse. So we should not try to eliminate uncertainty. Rather, we should try to ask questions like, how do we measure and use uncertainty? So this is the correct question which we should be asking. How do we measure and use uncertainty? Because uncertainty is somewhat inherent in machine learning systems, so we should not try to eliminate it. Rather, we should measure it and make use of it. Because of that, whatever outcomes we will get, that will be safe. If we take decisions using those outcomes, so that will be safe deployment decisions. Let us look at one example, like real world example. So if I talk about autonomous driving, like self-driving cars, unmanned aerial vehicles, so these are like autonomous driving. Now let us see a very good example. Let us suppose I have a self-driving system. Now this self-driving system, it did two observations, like it sees fog in the surrounding and it detects an object with 55% confidence. Now see here, very important point to be noted. The confidence is very less, like just 55%. So it detected an object, but with just 55% confidence. So very high uncertainty is there, because we don't know, don't, like we cannot say with confidence that okay, there is an obstacle is there or not, an object is there or not, because the self-driving system, it detected an object in front of it with just 55% confidence. So it is like very high uncertainty. So now ideally what we should do is that we have two like ideally what we should do is we should respect this uncertainty and we should take decisions based on that. And what is the correct decision we can take is the self-driving system should slow down, it should not stop. Why it should not stop? Because like the just 55% confidence, so high chances is there that obstacle is not there, there is a high chance that obstacle is not there. So like 50-50. So we should not stop, rather we should slow down and we should bring human in the loop. So we should request human control, because human, he will verify whether an obstacle is there or not. So this is the correct set of actions we should take. And here we are respecting the uncertainty, we are measuring it, we are taking into consideration 55% confidence and acting according to that. So that is the right way. But if you try to eliminate uncertainty, then what you will do? you will force a confident decision. You will force a confident decision, because see, the idea is that if you try to eliminate uncertainty, if you try to remove uncertainty, then what you can do? You can either stop the car or you can keep on moving. And both are like not the optimal choice. Because see, if you are stopping the car, then definitely you will be safe. But what if there was no obstacle? You will be wasting unnecessary time. And if you are keep on moving, then high risk is there. What if obstacle is there? Then you might collide. So forcing a confident decision, like if you try to eliminate uncertainty, it will make the system worse. And we should never do that. Rather, we should respect uncertainty. Uncertainty is something inherent. It's a property of machine learning problems. We should take into consideration and we should act accordingly. We should measure uncertainty. We should use it in a smart and sensible way. That's the correct approach. Okay, now we will discuss the last topic of this lecture. That is what machine learning is really about. So machine learning is about estimating likelihoods. Machine learning is about ranking possibilities. Machine learning is about making decisions under uncertainty. If we take an example of recommendation systems, so here the system, it does not know what the user will click. Rather, it estimates what the user is most likely to click. So that is what is uncertainty, because here recommendation system, it does not know with 100% confidence that what the user will click, because there are so many users are there. Every user will have a different behavior. How can the system know everything? It's not possible for the system. So rather, system will estimate what the user is most likely to click based on the historic records, past behavior of that particular user. So this is how the recommendation system works. So machine learning is really about managing uncertainty well. So machine learning system is all about managing uncertainty in the most optimal way, in a like a very smart way. So that is what is machine learning is really about. It's really about managing uncertainty and not eliminating uncertainty. So finally, we completed this lecture. So in this lecture, we saw that uncertainty is fundamental. It's inherent in machine learning. We saw that machine learning systems are inherently stochastic in nature. They are random. We should not eliminate uncertainty. Rather, we should manage it. We should measure it. We should use it. We should manage uncertainty. So I hope you liked this lecture. You got some good understanding, some good concept clarity. So do subscribe to our YouTube channel, Scale Up University. Share this lecture with your friends. Thanks for watching. Thanks for your time.